We think of the AI revolution as being virtual, right? But its physical footprint is causing a massive real-world backlash.
$64 billion. That's the value of data center projects in the US stopped dead by local opposition.
This quote really nails it. The boring buildings that power our AI, yeah, they've become community battlegrounds. And this isn't some fringe movement. We're talking over 140 activist groups across 24 different states.
So who's doing the protesting? Well, what's so interesting is that this resistance crosses all political lines.
Just look at the elected officials pushing back. It's almost an even split, 55% Republican, 45% Democrat. Sure, the reasons differ from the environment to grid strain, but the end result is the same, unified resistance. For the people who live there, the problems are concrete. Constant noise, soaring water usage, and losing green space. So, is this just about local complaints? Or are we seeing something deeper about our relationship with tech? This taps into a philosophy called neo-latency. And no, it's not just a blind fear of technology. It's about asking if all this so-called progress is actually worth the hidden costs to society and the planet. But while communities are protesting at the gates, a much more complex threat is brewing from within. They're called cyber-physical threats. Basically, they can turn an AI's own intelligence against the system it manages. So how do we stop that? Well, researchers have proposed a new layered defense to make AI more resilient. It works in 3 stages. First, accurately see the threat. Then, decide on a safe action. And finally, act carefully. And the result? Under attack, network lag is cut way down, which keeps everything stable and running. And crucially, way less data gets lost. This makes sure that vital information gets through reliably. This is a huge shift. We're moving from just building walls to engineering smarter, self-healing systems. Which leaves us all with a massive question. How do we balance digital progress with its very real-world cost?